So objective 1 for chapter 13 says be able to solve for an unknown value using either the combined gas law or any version of the ideal gas law. So the combined gas law, the ideal gas law with molar mass, with density, those are all on the pity page if you take a look at it. But the problem here says a gas in a fixed container with a volume of 5 liters is heated from 27 degrees Celsius to 150. So I've got two temps. If the original pressure was 1 atmosphere, what should the final pressure be? So if you look at this, you've got V1, T1, T2, P1, and they're asking about P2. So that's a pretty good hint that you should use the combined gas law. So if I plug in P1, the original pressure is 1 atmosphere. So I just plug in the 1 here. V1 is 5 liters. And then T1, you have to make sure you add the 273 to this. And that's on your helping hand as well. So 300 Kelvin. And that should be equal to P2, which is what we're trying to find. V2 is still going to be 5 because it says it's a fixed container. Unless it says it's an expandable container, it's going to stay the same size. And when I add my 273 to this, and then you just cross multiply and divide. So if I grab my calculator, take the 1 times 5 times 423, and then I divide by the 300 and divide by the 5. I'm coming up with 1.41 as my new pressure. And my label then would be atmospheres, which seems reasonable because my original pressure was 1 and I increased my temperature. And when pressure goes up, when temperature goes up, pressure should go up if you're holding volume the same. The second example I gave you for objective 1 says a 2.5 mole sample of gas in a fixed container with a volume of 5 liters and a temperature of 85 degrees would have a pressure of how many atmospheres? As soon as you see moles, you know you need the ideal gas law, because that's what makes the ideal gas law different than the combined gas law, is that it has N or moles in it. So can I clear the writing from the first problem? Haley, you got that? So again, if I look at the information I was given, 2.5 moles, that's N. Fixed container, so volumes staying the same, but it's V. There's temperature, and they want to know P, so PV equals nRT. P is what I want. V is 5. N is 2.5 moles. R, since it's in atmospheres, you look it up, but this is the 0.0821 R value. And then temperature, add to your 273, so 8, 15. .358, and when you solve for P, then your unit will be atmospheres since you use the R value for atmospheres. So 2.5 times 0.0821 times 358, and I can divide by the 5. So 14.7 atmospheres is what I could expect here. Make sure you label things. If you don't put a label on it, your number doesn't mean anything. If you say I got 100 right on my test, that sounds great until people find out it was worth 1,000 points. Then it doesn't really seem so good. So you have to give it some kind of reference.